Yeah, the ocean heat content. We could already jump into that. I mean, amazing. Graphics, great, interest level, in tune. I mean, the topic, just the fact that we're basically screwed. But like just how much energy the ocean like has absorbed. It's just a lot going on, but
I
how do
mean,
you feel?
in the 6 months since my first ocean heat content video, we've added 20% more heat energy into the oceans. I mean, yeah, I did the math. It's okay, it's 20%. Then when you stop and think about it, it's like, holy shit. I mean, you put aside the science. Oh, okay, we've increased it 20%. You stop and think about what that means. It's like, then it hits you. It's like, that is an incredible amount of energy.
Just
And
how
as I
much
showed,
zettajoules. Yeah, zettajoules. Go ahead.
yeah, 240 now approximately. And as I showed there, I mean, I was looking over that graph there in 1995. It's just like, there it is. And that's why I put that big arrow in there. I put that in there. That wasn't in the original. That's me. I did that.
The red
And
arrow
as
is the tipping point. The 1990s is when the change.
1995. That's
1995. Oh no.
that's my hypothesis that that's the tipping point for the planet when the oceans switch from no longer being able to sequester heat energy to basically starting to emit it. And of course, there's a lag effect. You emit it, so you warm up the temperature, but it takes, you warm up the air. It takes a little while for for the lag effect. This, that, and the other thing. But that's when we start adding all that energy, what we call heat flux. You put that heat flux back into the atmosphere. You start warming up the atmosphere. Oh, warmer atmosphere. Warmer atmosphere can hold more moisture. More moisture means more crazy precipitation events. Or, hey, we're warming up the atmosphere. Let's thaw out the permafrost even more so, and let's just keep adding to the positive feedback loops. And away we go to PETM.
We also documented that 2021 was the warmest year on record for the ocean, or just how much heat is in the ocean keeps
Yeah,
increasing year after
keeps
year.
increasing year after year, and we see it in the chart too. I mean,
Mhm.
2020 was a record. Oh, well, let's just blow that record by 14 zetajoules.
Every year it's another record, and it's just like, oh my God. But then we know that it's gonna get even worse than this, so it's just like you said the global average temperature is like 1.2 C right now.
That's the official. The oceans are a big battery, and now they've absorbed all this energy and the CO2 and the attendant heat, and now it's going to be discharged. So I then took it further. Says, oh, the oceans are a big capacitor, have stored all this energy. And what do capacitors do? They store energy, then they discharge.
I
So the
see.
oceans are getting ready to discharge the energy, and that means back into the atmosphere. That's why I threw that little graphic at the end. It's like, yeah, it absorbs the heat. It's going to eventually warm its way through the ocean, go back into the atmosphere. It will end up in the atmosphere eventually.
Yeah, it's so fascinating that graphic at the end because visual learners. But no, it's just how the whole
I'm one.
system is, yeah, me too. How the whole system is like that circulatory graph you see in like textbooks and stuff. But it's really showing like the severity of the climate crisis. It's like human activity. We're forced or putting greenhouse gas emissions in the air like every day. You see the factories, right? The Gulf
Yeah.
Coast, Texas, all these places where like the energy is big. And it's like all these gas things going up in the air, and you're just like, okay, I mean, that's that. We know that's gonna harm us, but we're doing it. Like, and then you talk about mass extinction events. I mean, this is it's a lot to unpack, basically. I mean, I still think you did a good job. It's a lot to unpack, but you did a great job. I mean,
Thank you.
I'm gonna link it and I'll link it below and above. And I just feel like, yeah, it's
It
definitely a good one to
I've been
learn.
getting a lot of positive feedbacks on that particular video. It's just like I'm just blabbering away, really. But it's just
No, I mean,
like,
there's graphs and stuff. And you talk about just like that tipping point, right? 1995, and just how you can see it's like blue and then just starkly red. And it's kind of like yeah, we're going straight up.
yeah.
It's
And
pretty
and then
alarming.
and then when I saw the Mediterranean data, it says, "Well, holy shit, here it is," because a lot of people not gonna know this, but and I mentioned in the video, the Mediterranean is the source water for the North Atlantic intermediate water, not the entire intermediate water, the entire Atlantic, but the North Atlantic. Because the mid latitude intermediate waters in the Atlantic, that's from Antarctica. In all seriousness, but and of course, it comes out Gibraltar, Coriolis axon, and just aims it. It's literally just aims it right at Fram Strait. So now you're heating up the Mediterranean, and you're bringing in this heat energy right into the Arctic Ocean. Is there any surprise there's no ice there, or disappearing rapidly?
Right, we're going towards this blue ocean event in the Arctic. I mean, just the rapid change of ecosystems is, I think, you're stressing, which I appreciate, because it really is severe and it's global. It's not regional. It's a global
Yeah.
issue, and it's pretty, the humanity level. It's hard to think about, like, because it just we feel so powerless, but it's the way we're
Well,
living, I guess.
the
Yeah.
problem is that because everyone doesn't look at the ocean, they think, well, we can just, suck out the carbon from the atmosphere and we're all good. And we can and we stop burning fossil fuels, we're all good. When they forget about the aerosol masking effect, they forget about the energy in the oceans ready to outgas, along with the CO2 to outgas, not just the heat, but the CO2. And then what do we hear? Oh, the UK is approving something like 6 coal-fired power plants, and then we have China building coal-fired power plants all over Africa. And then we hear Devoy from the post office basically giving a big middle finger to Biden, saying, no, we're going to buy diesel vehicles instead of fully electric vehicles that last 30 years. So keep doing this, stupid homage to the damn fossil fuel companies. And what are we doing? We're basically shitting our own bed, and we're basically going to guarantee our extinction. What we're doing.
I know everything we're doing is like an acceleration of like what we don't need to be doing. Like we're accelerating the issue severely, and everyone's telling us to slow down. They're like, "Nope, gear it up, let's go, woo, we're going." I mean, it's impossible. It's a runaway system with even human actions. Like we can't change. We cannot change. We cannot change. We cannot change, Jim. People can't change this fast, and this is the problem.
And you get the people who keep saying, well, the climate has always gone in cycles. And I'm like, so my comment to that was rate of change. Please learn that concept.
Okay. Oh my gosh.
I mean, in 270 years, we've done an increase of 1.6, 1.2. We've done that in 270 years, where it takes how many tens of thousands of years in the past? So it's the rate of change. And that's the other thing that really ticks me off, how the IPCC keeps moving the goalpost. First it was 1750. Oh, well, we don't like that result. Oh, 1850. Oh, we don't like that result. So the planet's only warmed up 1.2 C since the late 1880. Stop moving the goalpost. If you go back to 1750, it's 1.6. And I'm sorry, but even the fact of moving the goalpost, well, first of all, that's just poor science. Because if you're doing a study, you want to be consistent with your, wait for it, methodology. But if you keep changing the methodology, keep changing what you're going to use as your baseline, if you keep changing, that's changing your methodology. That's changing your analysis. That makes all your analyses suspect. And that's just simply poor science. I'm sorry, I am not going to sugarcoat that. That's just shit science. You shouldn't be changing the damn methodology like that. Now, if you're doing some studies and you find out, oh, this person has improved methodology or improved analytical resources, what have you, okay, you incorporate that, and then you do what? You put that in your methodology, due to the work of so-and-so and this year, so-and-so, whatever, we now do the analysis accordingly as that. But when you're comparing your data, which we have the records for, you don't just keep, what you're doing is, in essence, cherry picking the data. Once you start cherry picking the data, it's a slippery slope. Now, you take, for example, NOAA does the annual greenhouse gas index. I did a video on that.
Right.
They use 1750. In all their analyses, they use 1750. And that's the correct thing to do.
It's really the start of the Industrial Revolution. Is that just how they?
Yes.
Okay, so the history is
Yes.
important. Is why we
I
use
mean,
that.
it started in 1750. Sure, it ramped up starting in the 1850s because in England,
True.
Scotland, blew
Like
up
you said, it's the
with the
lag
coal
effect.
factories.
The lag
But it's the
effect.
lag effect. But then to say, well, let's make it the late 1880s. No. And next thing you know, say, well, let's compare it to 1905, and we've only warmed up 1.1 degree. You know what? I can compare it to 1990 and say we've only warmed up 0.3 degrees C. Nothing to worry about. I mean, shut up.
I know, right? So with the issue of cherry picking and moving the goalposts and consistency,
I mean,
yeah,
I
it's
mean, it's sort
suspect.
of like it's like, well, this team can have 12 players on the football field. Hey, wait a second. Oh, well, maybe we'll give him 13. Just have a couple extra tight ends, whatever, and extra blocking back, and then that's not fair. Sorry. I mean, that's almost like what they're doing here.
I see. What else? I mean, just the reality you talk about, the trajectory of where we're going. We're still talking about your ocean heat content video. I mean, there's a lot to unpack. Just the oh, okay, the 5 to 11 C trajectory, um, just by the magical year 2100. Last time I said 2300, but we're not humans will not be around to document 2300. But right, 2100 is our magical scientific year for all this. But just where we're going by that year is not a good situation. You said okay, here's why this is so interesting to me. I love when you talk about this on your video because the 4C issue, humans, if we get past 4C, okay, it's a little bit more complex than that. Do you want to
Yeah.
take it away? Just what going
It,
beyond
it,
4C is and the trajectory.
it's funny
Whew.
because I had one of my patrons saying, "Can you please explain this 5 to 11 C range that you mentioned?" And I said, "Yeah, I will make a video on that. I'll look for it next week. I just had some bunch of things to do this week, but basically, okay, we know there's a lag effect with the CO2 increase. Temperature follows behind that, but what we're now seeing is okay, and we've talked about how." What we're experiencing today is the result of the CO2 levels from 10, 15 years ago. So we won't feel the effects of current day CO2 levels until 10, 15 years hence.
Mm-hmm.
But now, and of course, with that warming, you then warm up the permafrost. The permafrost thaws, releasing more methane, and it goes on and on and on. But now what also is happening is warmer air can hold more moisture. It can also suck the moisture out of the ground. So now that leaves those areas prone to fires. And then you put more CO2 when the vegetation starts burning. Also, look at the fact that the Amazon is no longer a carbon sink. It's now becoming a carbon source. Now comes the oceans. And the oceans are throwing all that heat and CO2 at the same time. So if the curve is doing this, right? If the curve is doing this, it's not going to do that. And that's where you start getting the crazy trajectory of 5 to 11C, which is basically half of the way towards the PETM, which is the Paleocene Eocene thermal maximum, when temperatures were approximately 16 to 18C above pre-industrial levels. Well, you go screaming 5 to 11, that's basically halfway there within 300 years or so. It's crazy. And the whole
I know. Yeah,
ecologists basically think that an increase of 4C around there is sufficient because there's enough significant changes to the ecosystem, to weather patterns and how crops fare and so on, that humans will be extinct by the time you get about to 4C or so.
okay, I love it because this is so severe. But the issue is the 4C again. So right, I remember last time it's not when we get to 4C that all of a sudden everything is gonna change.
Right. Yeah.
That's that kept in my mind.
It's like 3.8 was still okay. 3.8 still
Yeah.
okay. 3.95 still good. 4, okay, you're dead. You know,
Instant kill, instant
it's
kill.
gradual. It's as you increase towards that level, you're gonna have die-offs and stuff like that.
Oh my
Because by the
gosh.
time you get to 4C, the last vestige of human population, wherever they're scattered about, well, that's the end of that.
Oh shit. Yellowstone blows. I mean, it's just like any, but that's what it is. It's mass extinction event. I don't know how else bigger you can get than that. I mean, oh my god, just what is like 90% plus of like all fauna and flora go extinct. It's just amazing.
Yeah.
I mean, the level of the
I mean, the
scale, I
last
guess.
really major extinction event
Oh
was the
yeah.
Permian. And we lost like 97% of all taxa on the planet, aquatic and terrestrial, fresh and salt water. I mean, it's like basically, all life was wiped out. And, and there's been other extinction events, but not to the extent of the Permian. And we're on our way to a Permian extinction type event here.
So we have like, can we view it as 1.2 out of 4? Is that what this is? I don't know. I'm trying to conceptualize. Like, yeah.
Degree of difficulty.
Because okay, I'm trying. Because it's just okay. Because we talk about the IPCC, right? Oh, we're trying to be under 1.5, 2 degrees C, but by 4. But okay, so the closer we get to 4.0 C, and we know the trajectory is 5 to 11. So let's just, we'll get there. But right now, focus on this 4C number, which should happen before 2100, right? So it's less than 100 years or so. But once we pass like 2 degrees C, we're in trouble, we've been told. So
Yeah.
it's just it's like you said, and I appreciate you giving us just the visual. Just once you hit 4.C or just 4C, then it's instant death, right? No, that's not how it works. It's this gradual level of like mass extinction towards this change.
Because what will happen is not only that things are getting hot, and then you start screwing around with you're going to get storms and precipitation patterns are changing. You're going to get flooding.
Right.
You're going to get crop failure.
Right.
You get crop failure. Oh, you get that there. What's going to happen? You're going to have mass starvation. What happens when you have mass starvation? You get a lot of people dying.
And you have a lot of vulnerable people too, right? So the world gets more dangerous. You're going to get robbed. That kind of stuff, just you have to watch your shoulder or watch over your shoulder, that kind of thing. It's more of a high stress. The moose are stressed, the animals are stressed, humans will be stressed for resources.
Exactly. And toss in overfishing, toss in that the warming oceans will stratify the ocean and chop down productivity. Oh, let's not forget, phytoplankton supply 55 to 80% of atmospheric oxygen. Well, geez, if there's no productivity, the phytoplankton ain't going to be emitting any oxygen. So we're going to see the oxygen levels go all the way down. So everything is going to cascade, and I can't help but snowball out of control.